Assalamu alaikum wa rahmatullahi wa barakatuh. So today we will discuss about another kind of method which is used for finding the solution to algebraic and transcendental equations, okay, nonlinear equation. So we will continue our discussion on solution to nonlinear equations. So today we will see the method which is known as the regular falsy, okay, regular falsy method, okay, and it is also known as the method of false position, okay, it is the method of false position, and this is used to find the solution to nonlinear, okay, it's better to use the term to find the root of non-linear equation. So here a solution means that actually it is the root of the equation. That means that for some value of equation, actually I can represent it as f of x. For some value of f of x, you will get the f of x is equal to 0. So let us consider an equation. Let us consider equation y equal to f of x. For some value of x, for some value of x, say xs, that is nothing but the solution or the root, we can say f of xs will be equal to 0, or we can say that y equal to 0. That means that suppose you have a non-linear graph, like this. For some value, let's say x is equal to xs, actually you can see that your y is equal to f of x, and here at this point you can say that y equal to 0. So we want to find this, okay, how to find this xs. So we have seen one method which is known as bisection method. Now we will see a method which is known as regular falsy method, okay. So listen carefully, what is the logic behind the regular falsy method? Okay, let us consider a function. I will use the whole page for explanation. Let us consider a function something like this. This is a non-linear graph. Now actual solution, you know that this is the actual solution. We can say that this solution is xs. We want to find this point xs, that is the actual solution, okay. Now before that I will first draw this little bit curved graph for easy explanation. Now you see, I know my solution is between some point A and B, okay. There are 2 points, initial points it is given. So some initial points are required here also. That's why this also coming under the bracketing method, okay, okay. This is a bracketing method because the initial solutions are assumed to be between A and B. So the solution is between A and B. Now I know what is the value of f of A. This is f of A, you can see here this is f of A, and at this point actually this is showing f of B. I will show here itself f of B. Now what is the idea of this regular falsy method? I will join these 2 points with a line first. I will join these 2 points with a line. Now you know that this is actually this is nothing but the line, okay. Now this point is actually we can say this is y and this is x, okay. Y is nothing but f of x, okay. Y is nothing but f of x. Now I have joined the line. Now what is the equation of this line? The equation of this line, I can say that the equation of this line is x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1. Now you know that what is this x1? X1 is nothing but your a, and y1 is nothing but f of a, and x2 is nothing but your second point, that means your b, and what is y2 is nothing but f of b. You know this is the equation that you have already seen in your high school mathematics. Okay, so the equation of this line, I am going to write it in the next page as x minus x1 is a, x minus a by x2 minus x1, x2 is b minus a. Okay, and also this is a, and y1 is f of a. Okay, so I am going to write this equation. So x minus x1 by x2 minus x1 is equal to y minus y1, y1 is f of a divided by y2 minus y1. So what is y2? F of b minus f of a. Now I can write my x minus a is equal to y minus f of a divided by f of b minus f of a multiplied with b minus a. So this is nothing but, okay, you will get this. Okay, now fine. Now you can see that this is crossing here, this is crossing at some point where you can see that at this point your y is equal to 0. Okay, so we will find this initial point as our solution. We will assume that our solution is here. We will assume, but our actual solution is here. This is our actual solution, but we will assume that our solution is here. After that, we will take this point as the new solution. So I am going to find this point, because you can see here that at this point y is equal to 0. So this is my new solution, x is 1 temporarily, but my actual solution is xs, where is the actual solution I have already marked with the red color. Now, but what is the speciality at this point? At this point y is equal to 0. So I will put my y here as 0 now, this y as 0. So x minus a is equal to minus of f of a into b minus a divided by f of b minus f of a. Okay, or I can say that my x can be found by, so what is the x at this point? That means this x, what is this x? How to find this? Because you put y equal to 0, then if your y is equal to 0, you will get this as x's. Okay, so that means y equal to 0. So you will get this as x's. Now this is nothing but, you can take this guy to the right side. That means this minus a to the right side, then it becomes plus a. So this will become minus of f of a into b minus a divided by f of b minus f of a. Then this minus a, if you move to the right side, then it becomes plus a. So you will get it as this plus a. If you solve this equation, you will get your x's. If you rearrange this equation, you will get your x's as a into f of b minus b into f of a divided by f of b minus f of a. So what is your x's now? X's is equal to a into f of b minus b into f of a, that means divided by f of b minus f of a. So you got the new solution by using, this is your x's. Okay, you can see x's 1. I will say this is my x's 1, sorry, x's 1. This is my new solution, x's 1. So you can find your x's 1 using this formula. But in bisection method, you will find your x's 1 is a plus b by 2. This is the equation in bisection method. But in regular falsy method, you will find your x's 1 by using this method. That means a into f of b minus b into f of a divided by f of b minus f of a. This is for using regular falsy method. Okay, regular falsy method. So this is the formula. Now you have to remember all other procedures are same. Now what you are going to do is that this is your new solution. Now you see, now you are going to find where is your point. The corresponding, this is your f of x is 1. Now you will see where is the solution. You see this interval. Now you see that this f of a is positive and f of x is, sorry, not positive, it is negative. This is negative because 0 is here. So this is negative, and also this is also negative. So there is no solution in between a and x's. So if you take a and x as 1, no solution, actually no solution between these two, no solution in between a and x's. Now if you take this point, that means you know f of b is positive and f of x's is negative. One is negative and another is positive, so that the solution is between your x1 and your b. So solution exists here, solution in between, okay, x1 and b. So new interval now become, now the new interval become, you see here, this was our new interval become, this is your x1 and your b. That means that your new interval is between xs1 and b. Now this is your new a, and your new b is nothing but your old b. Now you will continue like this, okay. So we will see a problem. The procedure is same as before, but only difference is instead of this formula you will use this one, okay, this one. So we will see a problem now. So the question is, use the false position method, okay, false position method. It is also known as regular falsy. False position method, find a root of the function f of x, this is the function, is e power x minus 3 into x square to an accuracy of 5 digits, or you can say 4 decimal places, okay, 4 decimal places. The root is, so this is a question anyway, the root is known, to lie between 0.5 and 1, okay. So this is the question. So it has been given that your f of x is e power x minus 3x square, okay, and your a has been given, this is your a is 0.5, okay, and your b has been given, this is your b, which is equal to 1. So the root is between a and b, okay. So root is between a and b, that means that this is a comma b, that means the root is between 0.5 and 1. You have to find the root, okay, by using the regular falsy method. So first of all we will see what is f of a and f of b now, okay, for the convenience. So what is f of a? It is nothing but f of 0.5, which is equal to e power 0.5 minus 3 into 0.5 the square, which is nothing but 0.8987, okay, 872, and f of b is equal to f of 1 e power 1 minus 3 into 1 square. So you will get this as minus 0. Let me check it, okay, minus 0.28172, okay. So you see here that definitely the root is between a and b, that means this is positive and this is negative. So root lies between, so root is between a and b, okay. Now we will draw the table. So this, you can draw the table according to your convenience anyway. So you can use the same kind of table here also, like in the bisection method, or you can draw like this, the iteration index, okay, iteration index, then you know what is a, then what is b, then f of a, then f of b, then okay, I will just draw this f of b, then x's, then f of x's, then the error, okay, error, and it's a relative error anyway, relative error, okay. So this is what I am going to do. Now I don't know whether I can write, suppose I write here, okay, it's little bit problem now. So I will just rearrange again the table, that is better, otherwise I will not get the space for writing it. So this is f of b, next this is x's, next this is f of x's, then this is the relative error, okay. So relative error, how can I find it? The relative error, you can use the relative error concept in the previous method also. So relative error E is equal to previous error, okay, the previous value, not error, the previous value, that means the value in the n minus the present value minus previous value, the present value, that means in the nth iteration, minus the previous value, that means in the n plus 1th iteration, divided by previous value means n minus 1th iteration, sorry, previous means n minus 1th iteration, divided by the present value, that means the value in the nth iteration. We will see how to find it anyway, okay. So this is the definition for your relative error, okay. Now we will see with the first iteration, okay, iteration 1, 2, 3, 4 and 5, okay. Now we will see the first iteration. At a is equal to 0.5 and b is equal to 1. And what is f of a? F of a we have written 0.8972, okay, 0.8972. This is f of a, and f of b we have already written as minus 0.28172, minus 0.28172, okay. Now we will find what is x's, but what is the formula for x's? X's is not a plus b by 2 as in bisection method. We have a different formula. This is our formula for x's1, okay. So I will just use x's1 here, x's1 and f of x's1. It is nothing but your b into, what is that formula? A into f of b minus b into f of a into f of b minus b into f of a, divided by f of b minus f of a, right? Let me check it again. Yes, f of b minus f of a, yes. So this is a formula. So if you use this formula, you know what is a, you know what is b, and you know what is f of a and what is f of b. You substitute here. Now I will write it, that is a into f of b minus b into f of a, divided by f of b minus f of a is your x's. So for n equal to 1, what you will do, you know what is a, okay, this is your formula. So your a is equal to 0.5 multiplied with f of b. What is f of b? Your f of b is nothing but minus 0.28172, minus 0.28172, okay, minus b is 1, and what is f of a? F of a is 0.8972, okay, 0.89872, okay, I forgot to write it, yes, 0.89872, okay, 89872. So 0.89872, 0.872 divided by f of b minus f of a. F of b is minus 0.8172 minus f of a is 0.89872. Okay, so if you calculate this, you will get your solution as 0.88067. So this is for the first iteration. Okay, this is for the case with n equal to 1. So for n equal to 1, you will get 0.88067. Okay, 067. Now you will find f of 0.88067. You will get it as 0.08577. Okay, so I will write it 0.08577. So you got it. Now you want to find the relative error, but what is the formula for the relative error? You are in the iteration 1, so you have no previous iteration now, so you cannot find the relative error now. Okay, just keep it blank. Okay, now we will see the second iteration. Now you see here that f of x, this is positive number and b is negative number, so the solution is between b and x's. Okay, b and x's. So the solution is between b and x's. So what is x's? So I will write this x's here. I will write my x's here. My x's is 0.88067 and my b is 1. Now I know what is f of x's. So this is my new a. So this is my new a now. That means our x's 1 become new a now, and b become our old b, because the root is between x's and b. Because the root is between x's and b. So if I draw it, you can see that the root is between x's and b. Okay, so the root, it is like this, not like this. So the root is between, this is your b and this is your x's is here. So the root is between b and x's 1. Okay, that's why in the n equal to the first iteration. Now what I am going to do, now what is f of a? What is f of a? That means f of 0. That is nothing but 0.08577. Okay, and what is f of x's? F of b. What is f of b? F of b is nothing but minus, I will just repeat that value itself. Okay, that value itself. So what is the f of b? F of b is nothing but same value, that means this one, minus 0.28172. So I got it. Now I will find my new x's by using this formula again. For n equal to 2, for n equal to 2, I will use the same formula to find xs1. So I will use the same formula. So I will get the answer as 0.90852, and f of x's I can calculate by using the function. Anyway, this is nothing but 0.00441. Okay, how to find f of xx? That means you just take this value and substitute in the equation this one. Okay, this is the equation, so you will get the value. Okay, now that's it. Now you can find what is the relative error. So what is the relative error? Relative error can be found by the present solution. What is the present solution? The present solution is this one, 0.90852 minus the previous solution. What is the previous solution? The previous solution was this much, so minus 0.88067 whole divided by the current value. What is the current value? The current value is, because that is the formula, the present value is nothing but 0.90852. So you will get this answer as 0.03065. So this is showing actually the convergence of the algorithm. Okay, as you proceed, this value becomes smaller and smaller. Okay, now you got it. Now what I am going to do? Now you see here that f of x's is positive and f of b is negative. So the solution is between, and f of a is positive. So the solution is between b and x's. Okay, because you see x's is positive and our f of x's is positive, sorry, f of x's is positive and f of b is negative, but f of a is positive. So when we compare to f of x's, our new point, b is having negative value, but a is having the same sign. So there is no solution between a and x's, but our solution is between x's and b. So our new a become our new x's. So I will third iteration, it's become 0.90852. Okay, and our other point is b. So our b is now, what is our b? Our b is actually 1. So I will just write here our b itself, here itself. So our b is nothing but 1, and f of a is f of x's. So what is it? It is nothing but 0.00441, and f of b is nothing but, you already know this, it's minus 0.28172. You got it. Now you can find the new x's by using the same formula that you have already used before. You know what is b, what is a, what is f of a, and what is f of b from this particular row. So you use it and you will get the solution as 0.90993. Okay, now you can find f of x's as 0.00022, and you can find the relative error. How to find the relative error? The present value. What is the present value? The present value is this one. So 0.90993 minus, what is the previous value? This is the previous value, minus the previous value. What is the previous value? 0.90852 divided by the present value, 0.90993. Okay, now you will get, okay, I will just remove this line. Okay, now I will just join all this together. Now I will get this value of error as 0.00155. Okay, that's it. Now I will remove this, okay, and I will join here. I will join here. Okay, that's it. Now you see in the next iteration, this is positive. Okay, and f of b is negative. So the solution is again between, there is no solution between a and x's. The solution is between your b and x's, because this guy is positive. So you have to check for the negative sign. So where is negative? The negative is coming for the b. So f of b is negative. So the solution is between b and x's. Okay, so the solution is between b and x's. So what I am going to do now, the b I will write it, and so the solution is between b and x's. So first of all I will write x's, because x's is a small number, 90993, and b is 1. Okay, and f of b, you know what is f of b, sorry, f of a, you know what is f of a. F of a is nothing but 0.00022, and f of b is nothing but minus 0.28172. Now you will find the solution using the same technique, by using the same formula here. right? You know this, a into f of b minus b into f of a by f of b minus f of a, and you know what is a, b, f of b, f of a, etc. Okay, now you will find it 0.91000, 3 zeros are there. Now f of x is, you are getting 0.00001. You see it's very close to 0 now, f of x is. That means we are closing to the solution. We are approaching the solution. We are very close to the solution. Now the relative error, how we can find it? We will take the new value, that means 0.9100 minus the old value, that means this one. I will put it here, 0.90993 divided by my new value 0.91000, right? That's it. So you will get this solution. I will just write it again. So what is that? We will first put 0.91000 minus then 0.90993 divided by 0.91000. This is equal to, our solution is, our error is 0.00008. Now according to the question, you see here that we need an answer which is accurate up to 5 digits or 4 decimal places. So 4 decimal places should be same. 4 decimal places should be same. So if I compare our solution here, this is 9099 and this is 9100, but till now we didn't get the convergence. So we will try for one more iteration because it's not same. 9099 is for third iteration and the fourth iteration it is 9100. Both are different numbers. Only 0.9 is same in both. You can see the 0.9 is same, but the next numbers, so it is only accurate for one decimal place. So this is the fifth iteration now. So in the fifth iteration, you know that this is positive and f of b is negative and f of a is positive. So the solution is now between, if you compare, this is positive, we need a negative sign. If this is negative, we need a positive sign. Now we need a negative sign. So since this is positive, so the solution is between x's and b. So what is x's? X's is 0.91000, and what is b? B is 1, and f of x's is 0.00001 and f of b is minus 0.2817. Okay, so what is happening here now? X's you can find using the same formula. You will get 0.91001. That means that if you see the first 4 numbers here and here, both are same. That means according to our question, we need for 4 decimal places. So the 4 decimal places are okay. So we will stop now. And f of x's, if you calculate, you will get it as 0, and the relative error become 3.7952 multiplied with 10 power minus 6 if you calculate. So our solution is, our solution accurate to 4 decimal places is x's is equal to 0.9100, right? This is my solution. So what is happening here actually? Why? You can see when you compare with the bisection method, you are getting the answer within 5 iteration now. Okay, just you are getting the answer within 5 iteration. So this method is little bit fast when compared to the bisection method. So this is a fast method. This is fast when compared to bisection method. So which is fast? That is the regular falsy method is actually fast when compared to the bisection method. So this is something more good than the bisection method. So what is happening here actually? You see, I told you, you have a function something like this. For example, you have a function like this, and this is your a, and this is f of a, and this is b, and this is f of b. Now you will draw a line. Basically, you will draw a line. After that, you will get a new point that you will call x1. Then this is your f of x1. You see that is negative and this guy is positive, so the root is between your x1 and b. So now what you are going to do, now you will draw again, this is your new a, so you will draw a line between this and okay, this one. Okay, now you are getting a point, a new x1 here. Okay, now you will find what is f of x1, and you see this is negative and this is positive, so the root is between your x1 and your b. So again you will draw a line. Now you will draw a line between these two again, and you will get here some point. So this is your new x1, this is your new x1, and you will find here a point which is f of x1. Then you will draw again between. That means that you are moving towards your actual solution. So where is your actual solution? Your actual solution is, this is your actual solution. This is your actual solution. So you see here that you started with n equal to 1 from here, then n equal to 2 you are here, n equal to 3 you are here. That means you are moving like this, right? Okay, that means you are moving like this and moving towards the solution. That means you are moving towards the solution, moving towards the solution. Okay, this is the regular falsy method, regular falsy method. So the same thing is actually happening in the bisection method, but you see here that this movement is very fast. Initially you were here for n equal to 1, and for n equal to 2 you are here. That means you are jumping from this much, you are jumping, then you are jumping again, so that you are moving towards the solution very fastly. So this is nothing but the regular falsy method. So if you have any doubt, you can message me. I think it's clear to you. Okay, inshallah we will see one more problem in the next lecture. Okay, thank you.